Kind of felt like I was getting up in the middle of the night today. It's fine. I always have a trouble with the daylight savings transition. Okay, let's go on this first one. If you want to, if I were you, I would add the word Pythagorean up here next to identities, because on my topic list, I said Pythagorean identity. It'd be great if you knew what that was, and that's this. Okay. Use Pythagorean identity to find the value of each expression. Find tan and cosine if sine is negative 3/7 and cosine is greater than 0. Okay, the first thing we're going to do is figure out the quadrant. So I'm going to put a little parentheses up here so I can figure out what quadrant I'm in. And this says sine is negative. Sine is the y. So that's telling me I have a negative y. And this is telling me cosine is greater than 0. Cosine is the x. Greater than 0 means it's positive. What quadrant has a positive x? Nope. Negative what? 4. Beautiful. Quadrant 4. So that means I'm going to draw a little bit of quadrant 4. I'm not going to draw the whole circle, just this part that gives me quadrant 4. And then I'm going to draw a generic triangle. I don't care about the dimensions of it. It just needs to look like a piece of a bow tie. So if you're thinking about how a bow tie looks, this is how that corner of the bow tie would look. Okay, any questions so far? Let me pause there. I've done a lot of stuff already. I determined the sines of x and y. I used that to help me get the quadrant. And I drew in a generic bow tie triangle for that piece. Anything else so far? Okay. It's telling me that y is negative 3/7. So I'm going to put the negative 3/7 on the y piece of the triangle. It says cosine is greater than 0. That's what I'm going to solve for. And then the radius is always 1. X squared plus y squared equals r squared. X squared plus negative 3/7 squared equals 1 squared. X squared plus 9/49 equals 1. Okay, really quick. When you square a fraction, make sure if it's negative to make it positive. Also square both the top and the bottom. X squared plus 9/49 equals 49/49. So next step is to get a common denominator. Okay. X equals plus or minus square root. So I just want to go through the steps of this kind of slow. Okay, are you guys okay with this so far? I squared the fraction, got a common denominator, subtracted, and then took the square root. I haven't done any simplifying yet, but are you guys with me so far? Perhaps? Okay. X equals plus or minus. I'm going to make this root 40/7. Okay, and then over here, Okay, now we need to choose. We must choose positive or negative, and look back at your picture. It's saying X is this way and cosine is greater than 0. So I want to choose the positive one. You do not need to put the plus there. I just was trying to do it for effect. Okay, now interestingly enough, you're not done. This is normally where you've been done in the past, but this asks you for two things. It says find tan and cosine. We did cosine. Now we need to find tan. So over here, I'm going to put x is 2 root over 7. Okay. Now a reminder, we're going to write this if you have room down here. Tan is opposite over adjacent, or sine over cosine, or y over x. All three of those things are the same thing. It just depends on how your brain works best. Which one do you like the best? For me, on this one, I go with sine over cosine just because I have sine labeled and cosine labeled at some point in my problem. Okay, so over here, I'm going to say tan is sine over cosine. Do you see where this came from? And do you see where this came from? So sine is here. Cosine is here. Sine is from the problem. Cosine is what we got in our answer. Okay, now on these problems, you will notice that the denominators will cancel out. And a lot of times you'll notice that you have a root in the bottom, which is a problem. Notice you don't need to multiply by the 2, also just the root 10 part. I would prepare for it. You have a note card. I would put this problem on there. But before I move on, do you guys all see where I got the 20 from here? If you want to, you can just put that little deal in there if that helps your brain. Wow, that took forever. Okay. They shouldn't all take forever, but that one was that. That one was no joke. Okay, moving on. Yes, dear. Probably not, but you can always grab a piece of scratch and staple it on. Always okay with that. The reason I'm saying that is because I already copied the test and I have no idea how much room I left. What? Oh yeah. Oh yeah. She's on there all right. Well, you need cosine to find the tan. I don't remember, honey. I made this test like a month ago. I would just prepare for it. No card, no card. Okay, moving on. Convert each degree measure into radians and radian measure into degrees. Okay, this is radians. I got a pi on the top. I want to put a pi on the bottom to cancel. 180 is pi. Okay, now this, I'm going to use some tricks here. I'm going to be a trickster, trickeramus. I'm going to cancel the pi's. That's not the trick. But now I'm going to take 180 divided by 9 before I move on. So 9 goes into 180 20 times. 13 times 20 is 260. Yeah, it does not take as long as say number one. So I think what Connor's trying to tell me is maybe perhaps I could minus the space here and plus the space there. Okay, now I have degrees on the top. I'm going to put degrees on the bottom, pi on the top. Cancel out the zeros, and I'm going to have to go again, but that's okay. I noticed that those are both divisible by 3. Voila. All righty. Any questions about number 2 or 3? Those are far superior. We should have started with those. I'd warm your brain up instead of jumping straight into super Pythagorean identity, worst case scenario. Okay, moving down here. Find the exact value of each trigonometric function. All righty. So on these problems, it's very simple. This is exactly what we did in those 12 warm-ups. It just doesn't look like it. So right here, I'm going to go 180 divided by 4 equals 45. Which means that this is a 45, 45, 90. Okay, 45, 45, 90 is right here. The hypotenuse is 1, and the legs are both root 2 over 2. Okay, and what about the signs? We're in quadrant 3 here. Both negative. Yes, dear. Okay, are you asking about the sides of the triangle or the coordinate itself? Root 2 over 2, if it's just the triangle, is positive. But if you're finding the coordinate, you're going to have to go back and down, which makes them both negative. Isn't that fun? Okay, now I did too much. If you notice, this one is just asking for cosine. Cosine is the x. The x is this one. You don't have to find everything. It's just asking for cosine. I don't think there's a negative. But there is a negative on the chapter 10 test, for sure. But you'll have a lot more time. As a matter of fact, I made 4 warm-ups and 4 problems in the review assignment, chapter 10, that is just all negative. Okay. Next one. And if you notice, I'm kind of ignoring I'm ignoring this. The only thing I'm using from this problem is the denominator, so I can figure out what kind of triangle I have. So focusing on that, 180 divided by 3 is 60. That means that guy is 60 right there. So I'm going to find my 30, 60, 90 triangle. 1 root 3 over 2 negative 1/2. You guys see the negative 1/2 there? Okay, did I even need to find that though? No, because it says find sine, which is the y, which is this one. So I really could have stopped at the root 3 over 2. I find it's best to label the whole triangle though. Okay, number 6. 6 denominator, 180 divided by 6. 6 degrees? What am I doing? 180 divided by 6 is 30. That's the ugliest thing I've ever made in my life. Okay. Okay, now this one's tan. And it's the reason that I actually find all the things on the triangle all the time. Tan is y over x, or opposite over adjacent, or sine over cosine. All of those things are the same. So 1/2 over negative root 3 over 2. Okay, 2's cancel, and I have negative 1 over root 3. Rationalize. Voila. Okay, last one. This one's weird, but it's my favorite. This one is pointing directly to the axis, which means that this coordinate right here is 0, negative 1. And sine is the y, so the answer is negative 1. No triangles to do, none of that. You're on the axis, so it makes it easier. Okay, flip. Graph each function using radians. I like to start with a equals b equals p equals h equals k equals off the side. And down here, find the locator. Okay. A is 3. Everybody okay with that? Okay. B would be right here. Yep, it's 1. Period is 2 pi over 1, which is 2 pi. H would be right there in parentheses after the theta, but there's nothing there. So it's 0. K is 1. Any questions about those things so far? Okay, I like to start with graphing K, which is my midline. There's my K equals 1, and then I graph my amplitude off of that. Any questions so far? You guys good with the midline and amplitude? That's the easiest part. So locator point for cosine is h comma k plus a. So 0 comma 1 plus 3. Okay, and does that jive with the fact that this is cosine? Right? It's on the top. Okay, now how many boxes is 2 pi on this weird graph paper? Just pretend so 1, 2, 3, 4, 5, 6, 7, 8. Okay, now the unit circle has 4 quadrants. Waves have 4 pieces, so I'm going to break the 8 boxes up into 4 equal parts. So that means 2 boxes over, I'm going to make my next stop. 2 boxes over, I make my next stop. 2 boxes over, I make my next stop. And if I did it correctly, then the last one should be where on these notes, we're just going to graph the one cycle because I really want you to see that shape of positive cosine there. Oh, so I started my locator point at 0, 4, and then I ended my wave 8 boxes away. It's just because I wanted to divide that by 4 so that I know where to put the next dots because they have to be evenly spaced. So you could just make your, if you're like good at visualizing, you could make your end dot at 2 pi and be like, okay, well, I know it need to hit the bottom in the middle of that. And then like, do you know what I mean? Like some people have trouble visualizing like where to fit the whole wave in. So I just counted the boxes. I guess I'm just trying to appeal to different learning styles, but it's not really necessary. If you can visualize where the wave goes in there, then you don't really have to do that. Okay. Number 9, A is -3. B is 2. Period is 2 pi over 2, which is pi, which would be 4 boxes in this problem. H is positive pi over 2. K is negative 2. Well, everything that we do in this class, what do you do with it when you take it out of parentheses? Every single thing, polynomials, graphs. Uh, Let me rewrite it for you. What do you do? No. What does x equal from this?
-4 and then x equals 4.
Yeah, okay, and x equals 5. So this would be adding pi over 2 to both sides, so it'd be positive pi over 2. Also, notice that the formula has a minus here. That would make it positive. Okay. All right, locator point. This one is sine. Sine's locator point is just HK regular style. So pi over 2, negative 2. And I'm going to end my wave 4 boxes away. 1, 2, 3, 4, because that's how long pi is on this graph paper. Okay, and now I've got to fit my whole sine wave inside these little 4 boxes. That means I'm going to go over 1 box to get to the top, over 1 box to get to the middle, over 1 box to get to the bottom. Oh, crap. Forgot, 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 forgot. Thank goodness you're all here. Okay, there she is. Negative sign. You have no card.
Yeah, all the other parts are just knowing what.
Yeah. Like, you mean like this particular shape for a pot? Yeah. I would draw like a positive cosine and I would draw like a negative cosine. You know what I mean? Like, just make a little baby sketch of it. Um, okay. Feels like we've done a lot, but we still have 4 more to do. It's not my best, but it's not my worst. Okay. So to start with this, I think everybody's pretty good with the labeling the x-axis and sort of visualizing where the angle will be. This is 30, the reference angle is 30. However, this is very important. Do you see how the problem is in radians? That means your answers all need to be in radians. I cannot say 30 degrees for my reference angle. Okay, now I use the 30 degrees to help me draw it, but for my reference angle, I'm going to say 12 pi over 6 minus 11 pi over 6 equals pi over 6. That means that this angle right here, quadrant 1, is also going to be pi over 6. Reference angle is always the same as the quadrant 1. Oh, that's bendy. I don't need to find quadrant 4 because the original one was in quadrant 4. Okay, now coterminal. I need to take my original angle and add 2 pi. Okay, what label up here on the circle is 2 pi? 12 pi over 6. It's already up there. So my positive coterminal is 23 pi over 6. And then for negative coterminal, you just subtract 2 pi. That. Okay, so what happens in Vegas stays in Vegas. What I mean is when the problem's given to you in radians, the answer needs to be in radians. Now, I think someone, I can't remember if it was in this class, multiple classes, asked me, is it okay if I do the whole problem in degrees and then convert every single one into radians? And I said, sure, you can spend all day doing them all in degrees and converting them all to radians. If that's what you want to do with your day, that's fine. I would just prefer to subtract one and add one, and that's what I do because I'm lazy. But if you like to grind it out in degrees, by all means. I do not care. Okay. Now back to polynomials. Later that day, Factor each completely and find all zeros. 1 0 has been given. Okay. First, you notice that this one has an x, a common factor of x. You do notice it? Okay, let's take that out first before we start. Okay, and what do I do when it's a fraction? My 0 is a fraction. What do I do to make that into a factor? 5 in the front. And it's -1 because we switched the sign. Did we do it? Looking like clock one in a row. Ah. Okay, so that's as factored as that can get. What is 25 minus 32? -7? Oh, that's excellent news. Yep, this is on there. It's the two 5-point problems at the end. Just when it feels like you've done a whole day of math, you've got to flip to the other side. There's actually dos mas. Oh, good. I think everybody's pretty much got this mastered though. Like, I'm expecting full credit on like all these. Yeah, the only thing was like on the quiz, a bunch of people um messed up in the box and then we're getting remainders, and at least they knew they weren't supposed to get a remainder. They were like grinding like little negatives and positives in there. But they just kept going till they figured it out. So that was good. Okay, two more This one, we get to do factored form. Woo! Okay. What? You want to do standard form? We can do standard form on the next one. Okay, so we have a double root of 5/2. So I'm going to say 2x minus 5 squared. Does that make sense? The 2 goes in the front and switch the sign, right? And then double, and then x minus 1. Is there any questions about my setup? Are you sure? We're good? Okay. 5346 equals a 2 times 7 minus 5 squared. 7 minus 1. 14 minus 5 is 9. 81 times 6. Final answer. Not too bad. Okay, last one. Write a polynomial function, blah, 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 zeros. Okay, this one is complex. That means that he needs his best friend, the conjugate, who is 1 plus 3i. This one does not have a point given with it. It might on the test. Actually, I think it does on the test. So you're going to have to do this business and then put the x and y in. No big deal. But when we write the factors, make sure to switch the sign on everything. So x minus 1 plus 3i, x minus 1 minus 3i. Don't just switch the signs on the 3 i's. You have to switch the signs on everything. Okay, this is a 3 by 3, but they're conjugates, so we don't have to do the whole thing. You guys all see where I got the positive 9 from here. Yes, positive 9. You all see where I got the 10 from. Okay, so if you guys could flip to the stamp sheet side real quick. Okay, so we are here. Notice that the review assignment is the homework, but it's not one night's homework. It's due on the block day. Tomorrow in class, we're going to be doing the team test. Now next thing I want to talk about real quick before we're done. Is this, okay. Your next test is on the block day, either the 19th or 20th. It's not this week, it's next week block day. For your test, you can use the note card and calculator here on the topic. Given a trigonometric function, I put in parentheses, that means a sine or cosine wave. Choose the correct graph. So it's a multiple choice question, you have an equation, you gotta kind of work it through, figure out which graph is correct. Okay, second one. Sketching an angle in standard position, find the reference angle, the angles in the other quadrants with that reference angle, and coterminal angles to the original angle. You know what that is, right? We just did it. Well, it is. It's also a multiple choice question, so yeah, it's not a big deal. Yeah, I like that. Okay, but y'all know how to do it, right? The quadrant thing and the thing and stuff. Okay. Third one, graph a trigonometric function. That's also a sine or cosine wave. Identify A, B, P, H, K, the locator point, and graph it. Okay, Pythagorean identity. Triangle A squared plus B squared equals R squared. Okay, now we have the two 5-point problems. The first one, factoring a polynomial completely, then finding and describing all roots. We just did that a minute ago. So factoring as far as you can, and then it's the backwards box, the dividing one. Which is, what's that number? What number was it?
13.
It was 11, yeah, number 11. Okay, and then the opposite way, finding the standard form of a polynomial given irrational or complex roots at a point. So that means you gotta do the boxes, plug in for X and Y, solve for A, and then distribute. Anything there that does not make sense? You have a week and a half. So, yeah, I think it's good. I think we've done it all, a lot of it. All right, work on your review assignment for a few minutes. Please and thank you.